So please welcome Zdenek.
Yeah, thank you for the introduction, and the topic is, as it is stated here, deliver machine learning to production. And I have also one question. Who knows Wandera? Who ever met the name Wandera? It's familiar? Perfect, at least a few people. Yeah, so we are a small startup from San Francisco, based in London, and here in Brno we are growing rapidly. Right now we have 50 people over here. Let's say the engineering hub of Wandera is situated here in Brno. And I'm going to speak for the work which was done in the team called Data Science, of course, which is David, Oscar, Ruslan, and me. David and Oscar, they are, let's say, mathematicians. They are the data scientists, and me and Ruslan, we are more engineering guys. So this presentation is mostly about the engineering part of our business. Yeah, Wandera is, let's say, lead according to Gartner in mobile threat defense and data management solution for enterprises. So we focus on big companies which has hundreds to dozens of thousands mobile devices, and they would like to have security there, and also to see what traffic is going through those devices and so on. And of course, because we are in enterprise, we have a strong relation to enterprise mobility management solutions and CM, because that's what the market is asking for. If this presentation is given by our marketing department, it would be, the agenda would be like this. For the marketing, all which is data science is just Miriam, which is profit from Bible, and it's black box with some nice colors, of course, delivering magic. So I'm not from marketing. I'm going to speak about what the backend behind Wandera is, and then the main topic will be PMML and open scoring. Might be that you are aware of those technologies, might be that you are not, and I guess this particular combination of technologies is very good for the startups to really deliver fast some nice machine learning based solution to production. And then I will speak about some boring things like integration, quality assurance, and things like that. So the backend. So over here, you as a user, when you are connected through the Wandera, means that you are accessing internet through the mobile gateway. You can think of it as a proxy, and the proxy is responsible for, let's say, controlling what you can access, what not, and so on. And of course, your device is sending some status updates either through EMM or directly to us. And of course, there is a backend, nice RESTful microservices, which gather some information or harvest information from the internet. We have also a huge data sets in various forms, and we can also get some information from the EMM. So where the machine learning can be applied over here? One solution is to put it on the device. That's a nightmare. So many platforms, so many versions. The support would be really difficult for the group of, let's say, 20 developers, which we have for that. So, or for the mobile, we have just a few of them. The next one is the proxy, let's say, the mobile gateway. Over there, topics or things like traffic classification. Is it Facebook or is it something else? Phishing detection. Is the page which is going to be shown to the user, is it a phishing page? Or is the gateway under attack of the hacker? So those are the questions which can be answered either by machine learning or something else. The problem over here is that you need to have the answer quickly. The user can't really wait for 1 second per request to be sure that there is nothing behind the nothing bad in the traffic. So we are speaking about milliseconds over here. And of course, when we have the backend and basically the traffic gets into the stream of events, then you can do whatever you want with the resources you have. So I will speak about the solution which we have either on the backend or in the gateway itself. And the topic is PMML, Predictive Model Markup Language. Basically, you can think of it as an XML. And we use it for the communication from the data science part of our team to the engineering part of the team. So it allows us to work on different architectures, different solutions. For instance, David likes Spark ML. Oscar is using Python sometimes. And you can really use whatever tool over here because the PMML is quite standard. It's here for some time, and there is a very rich support in various tools. So they produce some XML, which I will describe next, and then it's our responsibility to take the model, the trained model, and somehow use it in the infrastructure. So the XML has several parts. Basically, you can think of it as a model, trained model, with some pre-processing and post-processing steps. So what we get from them is, let's say, header saying this is this predictive model of that version. That means we know what API to use to communicate with this model. Then there is some pre-processing. Of course, there is a trade-off, whether the pre-processing should be done in the backend, in the microservices, or within the model. We choose to push most of the pre-processing to the services, microservices, because we have unit tests there, we have a logic there, all that metrics gathering, logging, and things like that. So in our case, the pre-processing is quite short, the same for the post-processing. And again, the decision is done in the microservices. So the output of the classification model is usually probability, and it's up to the service to decide whether this is going to be evaluated this or that way. The model itself is in XML. Over here is just example from the internet. You can see the neural network, one layer of that with 2 neurons with all the numbers there. So it's really a format which can be used to transfer the model from one side to another. 2 more things, model explanation. In PMML you can really specify some other metrics, or it offers you some other metrics to be measured, like ROC and things like that. In the model verification, you can specify a data set with expected results. So when this PMML is loaded to some target system, you can check that it really responds correctly. Yeah, and then the open scoring project, that's the, let's say, backend side of this. That's just a tool which we have chosen to take the PMML, load it into the memory, and really do the classification for us. And that's mainly because it has ready-to-use solutions. One of them is RESTful microservice. We didn't use it as it is, because we have our own microservice template with all the logging, security, metrics, etc. already set up. But basically it's just a shelf around this original solution. Yeah, one of the things which we learned is that if you don't have straightforward process to retrain the model, you have to wait for someone to come back from the location because he is the only one with the knowledge. So then we come up with this process. So basically we start with Jenkins. The Jenkins starts the model retraining. We are not running all the Spark clusters all the time because it's expensive and we don't really need them in the rest of the time. So the new cluster is created, the task is deployed there, it's run, and Jenkins is not really listening for the output because we don't really want to use Jenkins executor to monitor that. So once it's trained, the result is stored into S3. Then we have Amazon Lambda function there sitting, which is triggered by the store event to S3. It checks the test results, and if there is a problem, we are notified as the team. Of course, not by email because it's not startup style, so we have a Slack channel with Slack message, but that's just the detail. And of course, if the results are good, again, Jenkins is called to package and deploy that new model into our dev environment. So the next step, when we have the retrain model, is quality assurance. So during the retraining process, we perform cross-validation, as most of you probably do, which guides the training process and basically is one of the termination conditions. And then what we do on the cluster, because we have the power there, we do the impact estimation. So we take all the historical results or the subset of them, and we validate whether the new model is close to the last model. If there is a big difference, something might be wrong. If the difference is just minimal, it might be that we are really improving ourselves. Then we have manually crafted some data sets, so it's also checked on the cluster such that those results are there for the Lambda function to be checked. And of course, when we have the model in the dev, there is end-to-end integration tests written in BDD, so things like given a customer with a device trying to visit a phishing page, then something should happen in our infrastructure and the phishing page should not be accessible to the device, for instance. And of course, there is also space for manual testing, etc. if we would like to, and we need to really check that the open scoring really returns the same values as the Spark, which we use there on the EMR, such that we are sure that really open scoring is having the same model and is providing the same results. As for the monitoring, as I said, we have our own microservice template. It allows us to capture some metrics, sending nice logs, so we can have nice dashboards. And subsequently, we discovered that, for data science, this is not enough. So if there is kind of false positive, which you have usually, you really need to debug them, usually statistically, so you don't really need to have just one single line of the logs. So we discovered that the data scientist needs to merge something like 3 to 5 sources of information to really get the full picture what is happening. One of the reasons for this is that we decided to really do the feature extraction in the clients, in the microservices. So they basically encode the original message into the features. Feature 1, 2, 3 is 11. Feature 2, 3, 1 is 12. And you really don't see on the open scoring what's happening. What was the original information? Yep. As for the performance, I'm not expecting you to read all the numbers over here. This is open scoring service bombarded by some traffic, and on the x-axis there is time, 1 minute of the time, and over here is response time of the open scoring. The top 2 pictures are taken from a rather big model, which has more than 1 gigabyte in memory. And we discovered that when we use just standard G1 garbage collector, the response time doesn't go under, let's say, 8 seconds, and it reaches quite frequently higher numbers, like 20 seconds. Then we look on the garbage collector graph, and there was a strong correlation, really. So, first what we can do, just change the garbage collector. So we used parallel one. Parallel. 2 to 4 seconds all the time. Yep.
Very good question. Response time of what?
Of the open scoring microservice in this case. So basically the time between the traffic hits the endpoint and when the answer is provided to the caller. And on the second picture you can see a tiny model of just a few megabytes, which at the beginning has response time like 8 or 12 seconds, and then, pardon, no, this is not seconds, but something like 20 or 80 milliseconds, and now it goes down to, let's say, 20 milliseconds. So there is, at the beginning, when you load the model, you should really bombard it for a while by some other, let's say, data to make just-in-time compiler to kicks in to optimize the code such that you really get on the mobile gateway very low response times such that users really don't need to wait. And yeah, that's start of my summary. So the pros using the PMML allows us to clearly separate the two parts of our group, and it's really well done, so we don't really have much problems with each other, even though there is a Scala, Python, R, whatever on one side and Java on the other side. Easy integration with our infrastructure because we choose the right tool, in this case the open scoring. Models versioning allows us to really thoroughly put it through the QA, and it allows us also to roll back the infrastructure so we can load quite easily the last model. And of course pricing, because we are not running EMR cluster in each data center over the globe just because we need some, let's say, quick answers. Of course, nothing is perfect, so we can't learn online. There is still the retraining process, which takes from few seconds to hours, used to be days. So it's still something that can be improved. And yeah, some lessons. So create a reusable training process, so you don't need to wait for someone to come from the location. Avoid manual interference with XML file. It's very easy to really open it in your text editor and just change there something. Even if it is static value, you might not update, for instance, the version of the file, and then it's mess whether the service is using this or that model and so on. XML can be huge. What is in memory at the end in the open scoring is, for instance, just 1 gigabyte big model, but we discovered that the most memory consumed by the service is during the XML load. So all the instances must be really prepared for the XML loading, and then everything is nice. And yeah, finally, with the monitoring and logs, data scientists really want to have the full picture from the original data through the extracted features, response of the model, and hopefully in a very nice and variable way, for instance, in the database. Yep, and that's all from my side.
You had there a slide I couldn't see from the distance, the numbers. Yeah. So does it mean that JVM is many times faster than this G1 and parallel GC? Did I get it right?
No. Those are two different models. This one is a huge one,
okay.
Having more than gigabyte in memory. This one is tiny one, which has few megabytes.
Yeah, I thought it's a model,
It's
so
totally
it was
different
like...
because here I was speaking about milliseconds.
Yeah, yeah,
And
I
here
noticed
in
that, so I
seconds.
thought it's like many times faster. Oh my god, I didn't believe it. Yeah.
Just go ahead.
Okay. Actually, you were talking about the fact that you use this for the online validation of the requests coming through your like gateways, right?
That's one of the use cases.
And in the same moment, the response from the scoring service takes 1 to 2 seconds, something like that.
No. Again, different places in our infrastructure have different requirements. So on the proxy, we are focused on the time. The response time of the machine learning must be really in those milliseconds. So we can't really put there this huge model which has seconds to respond. So there are different use cases, different models, and we of course are tuning the models to have quick answers on the proxy. And we count with that, so of course the response, there are thresholds set that we know, okay, it's not accurate, but it's quick. And of course, in the rest of our infrastructure, in the backend, we can do stuff like that.
Okay, great, thank you.
Over there, one more question?
Yeah, just the idea about loading the XML. I assume that you use the open scoring as some implementation of loading of XML. Have you tried to investigate, like, change that into some streaming or something?
Yeah. We tried that as well. There is one of the ways how you can get the model into the open scoring is just by endpoint loading it. No way, it's timeout problem. So we are loading it from disk. Then we looked whether we can use other library to really load it. We investigate that, and basically there was not that much improvement in this. So we focused on making the PMML file a bit smaller, remove all the things which shouldn't be there and things like that. That also helped a bit. We did investigate. If you have any suggestion, I'm open to really discuss that, but right now the solution was just to increase the memory.
Yeah. Well, it's just one. So how much memory does the process consume?
Up to, I guess, 3 or 4 gigabytes of memory for the 1 gigabyte model. So it's not huge, really, but still.
Yeah.
If you go and ask for the money for this instance, every single megabyte is counted.
Does it really matter? Because if I get it correctly, once you load the model, you don't need this XML anymore. So this is basically happening only when you are deploying your model.
Yes, I'm not familiar with the Amazon and other providers' policies, but I guess you have to ask for the machine, basically, for the configuration, and then you can't really change it.
Okay, so you need just big machine just because you need to load this XML, right?
Yeah. So we did some optimization, so the models are not loaded concurrently, but sequentially, and so on. Those are those little hacks, let's say, to make it like that. But all this is just to minimize the costs, let's say. It's not a technical problem.
So one more question from me. You mentioned OpenShift on the slide. Heroku and OpenShift. Is there?
OpenShift.
I think it was just a list of features which are provided by PMML.
Okay. So then.
Yeah.
So ready.
This one. There are ready-to-use solutions other than the REST microservice.
So you don't. So because my question was like, if you would have OpenShift cluster, you would use some machine that would have some couple machines that would have like 16 gigs of memory, and then if you load it and you run the open scoring container, then it doesn't mean that if you run 3 containers, they all have to consume 4 gigs of memory, but it's kind of elastic. And then if one container doesn't consume that, other can. So then if you run multiple instances on a single node in such cluster, it would probably, we probably solved that already, but like,
No,
might be interesting
we are
to
thinking
take a
of
look
that.
at it.
It's already in the design slash MVP stage to really change the infrastructure. We have some technical debt in the operations, but yeah, we are going to use the advanced cloud technologies soon. The last question.
There's one obvious question. How many requests per second do you facing?
Per second,
Okay, per
Millisecond.
more than 100 billions a day. A lot. I don't know really what is the per second. It depends on which proxy, where in the earth, of course, etc. So it's very difficult to answer. But the traffic is huge and it's hugely parallelized. So we don't have problems, but we have to count with that.
Okay, thank you very much.